All right. The topic that we are going to consider today is a process. Process. Okay, process. Process. You probably heard of the term process, right? Multi-processing. Processor, then that is a hardware. Process. And in computer science, computer technologies, we many times say process. And also there is a similar term called job. So jobs and processes. Those two terms are very similar. Jobs and processes are basically built from your program that you designed. So we practiced just one time how Python program can work as a process. Then what is the difference between process and jobs? In Linux, they are quite different. But we work on sometimes process, sometimes jobs. So jobs is a terminology about the program that we build and we operate in the user view. So when you say user, then we see, oh, this is a job. Is my print job done? When you send the print, some documents to the printer, then that is a job. So we know, user knows there is a printing job. On the other hand, the process is more system. Linux kernel point of view, we call it process. So we can see the process, multiple processes currently running. I said running. So when the program that you develop is running on the computer, then we call that process. And multiple of those together, sometimes we call that, from the human user point of view, jobs. We call it job. Maybe print job consists of multiple processes. It's not just one single program can print everything, right? It has multiple other small pieces of programs or processes involved to make it possible, make the printing possible. That is process. So we started with something interesting. We want to install some of the interesting process, some of the jobs here. All right. Say fortune. Oops. I need to bring up my terminal. I thought that is my terminal. So go back here. To bring this to. Okay. First, I want to install one of the program called apt fortune. After that, if I do fortune, then it gives me a fortune. Like typically when you go to a Chinese restaurant, then you have a fortune cookies, right? Do they still provide your fortune cookies? So you can get a fortune. you'll be divorced within a year? Is it fortune? Why it says fortune? Unless ours. So William Shakespeare said something here. Okay. There's another way that you could do is Cowsay. Okay. Install Cowsay. Sudo apt. And then if you have an option -y, then it may ask you to enter yes or no, but I would say, hey, go ahead. Yes. That's what it is. Okay. Once we have fortune and the Cowsay together, then I want to pipe fortune, pipe, Cowsay. Oh my gosh. Better. I can do more. So when you send the email, you may say something like that to append to your email to your friend, right? Do not make it on your formal email. Something that you want to make your friend happy. We have more. Fortune Cowboy and what is that? Left out loud cat. Left out loud cat. Let me see if I have a left out loud cat. It is not, right? Then we have to install. Yes. So we can have a fortune pipe Cowsay, and then we can pipe one more left out loud cat. Oh, better, right? It's like a color. Oh, better. I'm not sure it's always better. If it is vivid, it may not be better. Melody and Levi, good to see you. Why are you coming together?
We were finishing our exam, our midterm exam for statistics.
Bright ladies. Statistics. So Linux has some statistics. For example, netstat. Some of the statistics about network, right? So lots of those. So if you want to see this pipe and more. What's more? You want to see that page by page, right? So you can see the page by page. Netstat active internet connections without servers. Types, stream, state connected. I know the path, some of the programs that is running. But anyway, this is something about the step. What else can you see? Oh, this is really good. NeoFetch. NeoFetch. Command not found. So we need to install NeoFetch. Yes. So if you do NeoFetch, it gives you some information about your system. So who is the user right now? Jae-yoon. Operating system, Debian, GNU, Linux 12, host, Raspberry Pi 5, Model B, yeah, 1.0. Kernel, some of the models. Uptime, only for 24 minutes, right? And then packages. How many packages that I have? 1,658. Those shell are currently running on my system. There is a bash shell, 5.2.15. And more and more. Sometimes we may not. And the terminal that we use is LX terminal. X terminal. But the L means lightweight, X terminal. It's not really X terminal. About maybe 30 years ago, X terminal was first became popular. Before we have an X terminal, the terminal that we have is not like this. It's a line terminals, only line by line. So no graphics can be emulated. So the concept of X terminal developed several decades ahead. But X terminal becomes first introduced and manufactured, I think, 1980s, when Macintosh first introduced. So, and also at that time, the terminals that can emulate the X terminal is very, very expensive. At least $5,000. One terminal, one monitor, one screen. Okay, CPU, 4 CPUs running, 2.4 gigahertz. This means microwave, right? 2.4 gigahertz is microwave. This determines the speed. So computer that runs right now on your Raspberry Pi, the hertz is a gigahertz, right? Hertz. Hertz means per second how many waves fluctuation, one cycle of wave. Our electric lights, 60 hertz. So per second, 60 times. It has cycles. Sunlight. Wow, sunlight that we can see. I think several 100 billion times, I think zillion times, a lot faster. Sunlights. I said visible sunlights. Sunlights that the sun light out is not all that we can see. We can see only a certain range of the frequencies, right? Anyway, there's something else. All right, so memory, that's the size of memory. 8 gig, right? Because it says 8,000 meg. So 8 gig. So that is also, some of the process can be installed. So we can, for example, if we combine much of those, then this is a one job that I made, right? For the user's point of view, this is one job, but it has multiple processes running. So you can play with this. This is not what I want to do today. Okay, process. So when some process is running, then we want to see the process. PS, this is the process that are currently on this session. But if I want to see all things, A, U, X, then that many. If I want to see that more. So not only the program that I operate, but program that owned by root, many programs owned by root is now are now running. So we call that process. They're all root and some other, right? So many processes running. Each process consumes some percentage of CPUs and memory and virtual something and resident some of those. Okay, it started 4 o'clock today. Okay, so those many processes are running. Top, when you say PS, then this tells you display about the process. For your job, if you say top, then it gives you the jobs, more like jobs. So you can also see, oh, we can see jobs, no jobs, top. So we can see many of those. Oh, we have jobs here. Okay, so top display and update the task. Good to monitor processes in active and running, sleeping, stopped, and zombie. So processes are when your program is loaded and being executed. Then if it is running, then we say that is active process. Active and running. And then there's some priority. Priority, according to the priority, part of job stops and another emergency process comes in and handle it. Meanwhile, the other process may be sleep. And when process is completely done, then for a while, that process will be called zombie. Okay? So for a few milliseconds, it is called the zombie and then disappear. Okay. I believe I have some of those pictorially. Okay, here. If you see this, there's a process state. So when you click a certain program or you type, then it comes here. Okay, so it is created. It is admitted to your the computer CPUs or memory. It is ready in your memory, and CPU says, "Hey, I want to run it. Run you. I will run you according to schedule." Then it'll become running. But there is some interrupt. Some other processor comes in and says, "Hey, I'm the first." Then this guy slipped away to ready mode. That is an interrupt. And then some of the process may need to communicate with the input and output. For example, your program says, enter your age. Then that program when it runs, it says, enter your age. And then there's your turn, human. So this guy is now going back to ready mode and wait for user's input. And when user type it, then it may come into running mode. So there is a waiting mode again. Oh, this is not interrupt. Yeah, running and wait for user enter and ready, and then running again. And then you can say, what is your annual income? And then waiting here. And when you say $550,000, eventually, right? Then it come here ready and running. When all the program runs, then terminates. When it is exit, meanwhile, we call that there is a zombie, okay? So you will be a zombie. That's what it is. All right? Okay, let's go back. So jobs can be sometimes pushed to background and bring it back to the foreground. So background and foreground coming back and forth. That is also possible. And also we can kill the process. This is a little different, complicated process, complicated steps involved. When you kill, I want to kill this process. Then a lot of other the computer components now still watching over that process. Process is running, but if you said I want to kill it, then it's not really simple to remove that processor only. We have to clean up some other things. This turns me on to the question that Gianni asked the last moments of the last class. Did you watch my recordings? I answered. I added extra recording. Anybody go back to my recordings of last sessions? So at the end, I explained something. Melody, you said yes, no? Nobody? Once you're done here, then you forget? Or you understand everything completely well? Or if I don't give you any homework assignments, you don't need to come back? Okay, go back to Johnny. What did you ask? Oh, you don't remember your...
It was more than one question though, so that's why I don't remember.
When was I trying to say something? No? You were asking about remove, RM. Remember that some of the mode we were not able to remove. I'll show it to you, my recordings. And also some of our online students may not remember that either. So I'll go back to point out I think this, right? All right. To come in, then you need to have here execute and B. So that works, right? So that I can do this. This is his file, so he can see it. Can be removed, but when I do this, permission is denied. So I looked at. I can remove it. Not only the removal of this individual file as an element, but since this element is contained. Right, that is the issue. Why we were not able to remove? While the container does not allow us to write permission, but I want to remove the containment, one of the containment, which is a file. I want to remove the containment because I have a write permission. I'll show it to you. Oops, I have this. So if I move to IASP 221, is it? So OCT 16, come back. OCT 16. Right now, this is the folder. This is the directory, right? Directory does not allow me to. When I am other, if I'm not Jae-yoon, but I am other, but there is no write. If there is no write permission, then I cannot even delete it. Write permission includes delete permission, right? When I write, if I remove everything and write it, then that means deletions, right? Somehow. So we have only 3 actions of a permission: read, write, and execute. So write is, if you have a write permission, then you can delete it. But this guy does not give us to remove if I am not Jae-yoon. So when I get into OCT 16, although I have, for example, this one, I have write permission, but I cannot. Why? Because, in this case, cyber, for example. Cyber, I am in the group of cyber. I'm someone else, right? But so that I have write permission. So I am happy to delete this. But when I go back, that is me. I can delete that individual file. But container contain that file. So I need to get the permission from the container. For example, Jiani, you are a member of your family, right? Do you love your family?
Yeah.
Yes. So your mother and father. So if you are still young, if somebody kidnap you, then what do you expect from your mother and father? They want to take you back, right? They do not want you to go. That is what exactly they can do. Container, the directory should give you permit so that you will be removed.
I sort of get it, but
There's a container and containment issue at the moment. Container and containment. Container, for example, I have here backpack. This is container. Here one small envelope, right? So I said, Android, you can take this. but I hold this. But he cannot take this while, as far as I do not give him to open my backpack, right? That's what exactly happens here in Linux. I need to open this, and then he can come in and delete. That's fine. But as far as I close, he cannot. As far as I do here OTC, I did not give him any write permission. That individual element write permission so that he can delete it. He think he can delete it, but not quite, because container still hold. It makes sense in real world example, right? Your family issue. I'm using. Oh, extra? I think I might. How did you know that I brought extra?
That was helping, so thank you.
Okay, that was the last time. So kill, like remove. Kill is not similar to that, but kill, the process, kill works anyway, because that enforced. Okay, that is very, very strong enforcement. So it go through. It's not like remove. Remove is lightweight. Kill, I want to kill the process. But the process, steps involved in this killing process is not simple. Okay, that we will know today. And there is another command called kill all. So let's look at those. Why monitoring process? Performance management, system stability, security awareness, debugging and developments, all, you can name it more and more, right? Monitoring process is one of the main job of cybersecurity professional needs to do. You need to understand what's going on your infrastructure. In your infrastructure, it's not just something, but it has Apache is running, which is a web server. MySQL is running. It has a lots of middleware running. Cryptominer, malware is also may be intruded and running. So much things that you may not know. There's a memory leaking, and also maybe your backdoor is open. How do you know your backdoor is completely closed or might be open? When you go home, you have a backdoor, right? How do you know that your backdoor is not open? Yeah, you have to make sure, right? You have to. Where there is a backdoor, then you have to check all. Then the problem is, in this program, in your system, each program may have there is some backdoor snippets attached. It's very hard to see. Then how do you know? You have to monitor the traffics. You have to monitor network traffics to see if any signals that you are not aware. Then you have to, what? You left your backdoor open? What? Tab? Yeah, tab is another monitoring. Yeah, we'll do that. Oh, right here, tab. Hey, you know. This is the very next slide. Okay, PS. the process that we looked at, right? PSAUX we already looked at. So display process. So PSAUX. Then we can see lots of process. This gives you the top most active processes display. So when you do this, hit enter, better display, right? Better than PS, command. So top is the command that you can monitor the process. As I said, what is a process? Process is nothing but a program, right? A process is a program. The program somebody developed. May not you. Maybe coming with Linux software packages. So I explained here. So all the columns. P, there is a process ID. This is keep changing, right? See it? So elements. I don't do much, right? This my Raspberry Pi doesn't do much, but still there is something. Okay, the owner. So BNC owner Jae-yoon, topmost Jae-yoon, and all other. There are many root, and there is a priority, PR. And on NI is niceness. PI is priority. NI is niceness. What is niceness? Who is good in the English the word niceness? Bishop, when you hear niceness, what do you think it is? What is? Let's say niceness is some indicator. Then niceness tells you what? You're not sure. Let's say two processes are running. Okay, more than two processes are running. Which process you think is nicer? Which process may be more aggressive? Some processes yields, hey, you do first. Then that is nice, right? That is niceness. Look at here. So that is a little bit opposite from priority. If there is higher priority, then low niceness. There's no such case that higher priority and also higher niceness. Explain.
Okay, well, I'm gonna try. Okay, so
You're right.
Since the process is basically monitoring the background in the order of what's happening in the background, I think niceness has to do with what program or package or whatever will allow the others to go before it.
Yeah, that's what it is. Yeah, that's what niceness tells you. See here, if niceness is minus 20, then the priority is 0. Of course, right? So nice, therefore, lowest priority. When my daughter was young, I always keep telling her that be nice to your friend, be nice to your friend. Now she's old, she complained a lot. Because you told me to be nice, my priority became lower and lower and lower. That is true, right? That you can see there. So if you are monitoring some of the process, you need to see this. Some programs, some command here, you can see the command at the end columns. You can see what it is running, right? Which one's higher priority and also relatively high niceness? That may be some of the attackers. Then maybe somebody aggressively designed that is somehow malicious program. So that is priority and niceness. VIRT, that is for total virtual memory. RES, resident memory, or sometimes RSS. SHR, shared memory. S, here state. Remember that process? When it is picked up and running, we say running, sleeping, and zombie. Here S means sleeping, so right now sleeping. I means, I think this is inactive. See something, yeah, a lot of I. Here R means running, right? That is currently running. Oh, top is running right now. Yeah, top, it reshuffling periodically. So if we have some other here, let's say netstat. And I want to push it to background. If you want to push it to background, then you can say netstat n%. Then it will run background. So you do not see that because it is running background. So maybe you can see netstat somewhere. It's not yet high priority. Top is most popular. Because of background, it's not really very active. That may be the reason. So if you want to make it foreground, so you can do foreground and %1, then it will become foreground. I want to simply run it. Oh, this is one time running. It's not really continual. So it goes. And then percent CPUs, which we know which ones currently running, consuming CPU the most. I think VNC is really CPU consumer, active CPU consumer, right? VNC is always top, up. Niceness, middle. 0 means middle. Negative 20, then that is the lowest. Positive 20, then that is really, really aggressive. So this is a top. So I want to kill it. Hard interrupt, hard killing. Then Control C. It will be killed. Okay. There's a little bit similar to top monitoring packages. We call that HTOP. HTOP is much nicer. Okay, watch this. HTOP. Very similar to the previous, but HTOP is really, really good tool. So I want you to use HTOP if you need to. Okay. There are many similar things here: HTOP, ATOP, glances, BTOP, BPY-top, and then GoTop, many others. I'm not going to do all, but there are similar command to top. Top is more primitive packages that you can monitor the process. So we may be able to see the memory, and we have 4 CPUs. So first CPU, and the second, third, and fourth. So we know the percentage of the consumptions. It's nicer, right? Gives you better, more information about process. Okay, so next slide. And then PS, we already looked at this, right? We can push it to the background and bring it back. Already looked at. Okay, kill. This is I said complicated process. Kill is a process to kill a process. So the way the kill command kills other process is to send the signal. Okay. So what kind of signals? If you want to quit it, then there's a function key, F10 to quit. F10, function key F10. Is it? No, this is not. I want to click this. Okay. So if you do kill and minus L, then you can see the signal. There is a 64 signals. So when you kill signal to a process, if you want to kill the signal by sending signal kill signal, like here, there's a number 9 signal, so you can kill that signals. For example, this is another terminal of mine, right? So if I see PS, then I think, no, this is this session only. So PS AUX, and I want to grab JUN. Oh, grab. Those are all from my JUN. So I want to see the terminal. This terminal. This is the second terminal. I need to figure that out. Lots of processes running under me. What are they? Oh, I think these all the libraries, which is some dependent programs when I run something else. Lots of those. Let me run one more time. Let's say bash. Bash is running right now. This is a grab. So this itself is my command, and I have 2 bashes, right? So one is I believe this is a process ID, PID. So 3137 and 2030, 17, maybe 2030. Probably which one is mine? I think TTY, this TTY 0 and TTY 1. So TTY 1, this bash is for the other terminal. So I want to kill this one, okay? 3137. So when I do kill 3137. This is process ID. When I do 3137, then don't do much, right? Because here, kill minus L. If I don't do anything, then not much that we need to do. So when I do option 9 here, kill and option 9, or this is a numeric code for this signal. When I say number 9, then equals to sig kill. That terminal is explicitly enforced to kill. Okay? So watch this. When I do this, if I do accidentally pick this process incorrectly, then my terminal may be killed. So I assume the other terminal, process ID is a 3137. So I want to enter. That goes away, right? So the other terminal goes away. How that happens, that is explained here. Excuse me. When I do kill 9 and process ID, so that issued, right? Then there is a sig kill, because number 9 is a sig kill. Remember the number 9 is a sig kill that we looked at, right? That signal is sent to the kernel. Kernel, that is core Linux operating systems. And that kernel schedule that removal process. So when I send this signal to that process is something, the victim, right? When I say, hey, you killed, then, sorry, Gianni is not be killed, right? There should be somebody should kill him. That is why kill number 9, kill process is not simple. I need to give a signal, although I pick Gianni, kill with the number 9, that is the signal. That command does not kill Giovanni directly. That signal goes to kernel, and the kernel will remove him. Oh, so kernel is really like Kim Jong-un. Right? Dumon, do you have some idea
Yes.
about the kill
Yes.
with 9?
Yes.
Don't do to anybody here.
If I get hold of the files, I don't know if I get in.
Oh, our boss.
I have a question.
Okay.
So, based on that flow over there that you have, a zombie is a process that doesn't.
That is at the end.
Oh, okay.
Yeah, when it is killed,
Ah,
then it will remain a zombie, and then eventually
it will-
cleaned out.
okay.
Yeah.
Thank you.
So you want to be a zombie? No, you are our captain.
No.
So the name zombie comes from there, Linux, originally.
Really?
Yeah. But when you do a lot of kills in Linux, lots of zombies at certain point in time, so somebody, oh, let me use that zombie.
Really? That's crazy.
Okay. Clear? All right. So environment, we looked at this last week, right? Last Thursday. Print environment. If we want to read a specific variable, then we can say echo $, followed by variable. So for example, echo, let's say print env, then lots of those, right? So if I want to see which one is really meaningful to us. Log name, okay, log name. Then echo log name is Jaeyun. That's the same as where am I? That something that we can see from ID. Or uname gives us the operating systems. Okay, and also we can see current prompt statement 1. There's a current prompt statement. Oh, this is either the semicolon. Look at the semicolon. That, and then the other one from the. No, not that semicolon. I'm sorry. It's a lot complicated than I think. Yeah. A lot more than I think. Okay, so if you can define a variable and you can export it to the environment, system environment, okay? Then you can do export. Export variable equal, don't forget, if you have any space before and after equal sign, it's not going to be defined. It's not going to be created. No space. Setting environment. That's right. Yeah, one of the setting environment that we have is profile. This profile is when your shell is first started, then according to this dot profile, that is based upon this, that is created. Your shell is started. So when you go back to your home, and if you do ls minus a, then all. If you want to see ls minus d and dot star, then you can see only something hidden files. This is ls dot star. If you do ls dot star only, then it doesn't give you. It gives you anything dot star, but recursively it goes into that directory. So if you do not want to, hey, I do not want to the directory, so minus d. No, minus d means I do want to display directory only. Okay, not go inside the directory. Then I do ls minus d dot star, then only dot something. For example, dot pki, there is a dot pki. Without this minus d, it goes inside. So this is a directory. Some containment also displayed, like dot local. That is somewhere here. That is also directory, right? So this guy said, directory only. Do not dive inside the container. So let's see dot profile. If we want to see dot profile, we have dot profile here, right? And also, this system level, there is a dot profile. So when you create your ID, then dot profile is copied from this etc profile. So you can see here etc profile, then that is owned by root, and then size is 801, right? What is my profile here? ls minus l dot profile. A little different, right? 801 and 807. If you want to see the difference, here's a command. There is in Linux there is a command called diff, which is not on your slide, but this is something that you need to see. So etc, because we have two files that look very similar, so I want to see. I do not want to compare manually by myself, but I know Linux may be more intelligent, so I want to ask him to run. So diff tells me. This is the first file, and this is the second file. Okay, so this guy, I think first file 1 to 2 lines, and second file 1 to 5 lines. So these 2 lines are from here etc, and next 5 lines are from mine. Okay, so a little bit. Okay, let's compare the other. 4 to 9 and 7 to 9. So we have here 4 to 9. And 7 to 9. It's not really well compared. It's not really very similar. It is not very similar. There is a reason. But if we have very similar, then this guy can compare very, very easily. But anyway, so when I see this dot profile, let's see what it is. This is a dot profile. When you log in, so that your session is first created and your shell is created, then this program is running. This is nothing but your Linux command, and we call this Linux script, like Python script. This is a script. Pound sign, that is command, like Python. Python command start with the pound sign, exactly the same ones. So explain that. / dot profile, executed by command interrupt for login shell. So when you first log in, then that is running. This file is not read by bash 1 if dot bash profile or dot bash login exists. If we have a dot bash profile or dot bash login exists, then our login shall start from this. Only if these 2 files are not available, then dot profile is running. Watch this. So bash login, that is this. Bash underscore login or bash underscore profile. I made this, right? If these 2 are already here, then this will not be considered. When you log in, then this will log in based upon this profile. That's what it is. But if those 2 files are not available, then this guy will come in to work. Okay, so in our current case, see, there is no bash underscore profile, bash underscore log in. We have a log out, but not log ins, right? If we do not have this, then which one will work? This profile. Okay, that's what it is. And then there's a umask 022. This is not, if you open this, comment out, then umask is set 022. If we have a umask 022, then what is the default file permission bit? That should be subtracted from 777, right? 7 first, third digit, 7 minus 0, then there's a 7. 7 means everything is everything is granted. Okay, read, write, execute. 7 minus 2 means 5. 5 can be obtained from 1 plus 4. So 1 is execute, 4 is read. So R dash X, R dash X, R dash X. When you do when you touch sample.txt, then this file by that by that definition, this is not, because that is not running, right? 022 is comment, it's not commented out. It's still, it is under comment. So it is not applied. That is the reason. Where is it? See here. If we remove this from that time, remove that. If you re-log in, and when you touch this, then it will be the current umask. What is my current umask? Well, still 0022. Then this is a 4. 4. 4 plus 1 plus 2, 7. This is not even 7, right? This is 4 plus 1, so 5. No. 4 plus 2, so 6. This is 644. 644. Maybe this is, oh, because of this, the first one is 0, so this one is, this mask is subtracted from, not from 7, but from 666. So if it is extracted from 666, then that is, what is that? 644, right? So this is a 644. Let's go back to. So cat, no, profile. So we looked at this. If it is a 022, then out of 777. So if we run mask. Okay, here. If a file exists here, bash dot bash rc, then we need to look at this home slash dot bash rc. This is a negation. If there is no bash version available, then we looked at this. This is a comment, right? Then we need to include dot bash rc. This is a comment. So how we can include? And we need to check the file. If this is available, then we include this. So this is done for that. Bash ready. Shell is ready. Once it is ready, then we need to check the directory. If there is a home/bin directory is available, then we need to set the path like this. Only if this is available. If it is not, then path is not really set. And then finally here, set the path so it includes user's private bin if it exists. Then we have to add that path to it. So look at this profile, don't do much, right? Not particular things that we do here. But anyway, this runs when you first log in because you do not have these two files. Simply, this will work. That is our case. Okay? So login process. Log out. When you have a bash logout, it will work. So in our case, we have a bash logout. See here, -d. Then we have dot bash underscore logout. So let's see, dot bash underscore logout. When you log out, that program runs. Shell level, if shell level is 1, then we need to, we run clear console. X means we want to execute the following. Okay? We want to execute this program, or we want to do this program and -q. This is when you execute. This clear console is nothing but inside it will be clear, like this. When you log out, clear that out. But when you log out, it's not really clear that out, right? When you first start up, this program runs. .bash rc. When you log in and then start up. I think we have that one, right? ls -d dot star, then we have .bash rc. This is the program. Log in and this program comes up. So cat bash rc, then this is if there is a file bash al is available, then include it. And if not, sharp-t, some of the commands. But anyway, this is something we need to look at this when it comes to Linux scripting topics. So script is a little bit similar to the programming codings. So if you do Linux script, then it can do so much things at once. That's what Linux script can do. By the way, after this class, we have a first tech meetings of Linux Club. I already sent it to you, Linux script that we want to run. That script, I want to explain that script, and then I want you to run it. That automatically create your friends the login ID, so your friends can come into your system. So we need to open your Raspberry Pi among our club, so that you need to protect it if you think somebody is malignant, malicious, malignant. Or you can open to your friends if you have some adversarial. That is a script. So script will come further later. So today, simply see there is this kind of program. That program runs so many the process. When you run this, then that is a process. Okay. So more about the process, we'll do the next class. So this is the start class. Lots of, see here, more examples. I prepared more examples, but we will do that, okay? Next week. No, next week. This is Thursday. So, any questions before we stop the class? Anyone? Any question, Chris? Question? Brianna, question? Brian? Joseph? Question? Okay. All right. See you. See you next class. So we'll resume our Linux club. Quick. I will stop my recording.